G'day and welcome to the video on addition of ordinances. This is exercise 4.3 in your textbook, and sometimes this is called the sum of two functions, as in SUM, not SOME. And what basically this is all about is just adding two graphs together. And we'll sort of have a look at that as we're going along. And when I say adding two graphs together, I mean adding the y values of two graphs. So for example, if I've got f of x and g of x being e to the power of x, and g of x equaling 2, as you can see, I've got both of those graphs there. One has got an asymptote at y equals 0, and the other one is just a straight line at 2. If I add these two graphs together, the sum of two graphs, or the addition of ordinances. So h of x is this new function, which is f of x plus g of x. Then just algebraically, I just do e to the power of x plus 2. Okay, I just add those two things together. But on the graph, essentially what happens is that each y value, that's what we're really looking at, each y value has been added together. So all of the e to the x values, which were down here, they all get added with 2. So essentially what happens in this graph is that the y asymptote is just moved up by 2. Now you probably would have been able to see that just by looking at the algebra of it, but that's essentially what's happened here. Now to add these graphs together, each individual point is raised by 2, as I mentioned. Essentially there's a couple of rules that I use for working these ones out, and this one is not really an exact science. This one is sort of a bit of guesswork. It's a little bit of estimation, so you don't feel like you have to get it perfectly. Most of the time these appear in multiple choice questions where you can clearly tell that your answer is correct and all of the other ones are false. So they're not going to be I don't believe they're going to be nitpicky over is it this distance or is it a bigger distance. They're just wanting you to do this sort of roughly, if you can sort of understand what this is. A couple of the rules that I go through is that the x-intercepts of either graph, the other graph stays the same. Okay, I'll show you that in just a second. I'll just go through the rules first. The other thing is, when the graphs intersect each other, the y values are doubled on the new graph. Again, I'll show you that in a second. And the other thing that I look at is any endpoints, because they're usually labeled, so it's easy to know what the y value is, and you can just kind of add that y value to the other point. And anywhere where it's you've got a bit that's above the x-axis that's about the same spot as a bit that's below the x-axis on the other graph, those two bits sort of cancel themselves out. Again, I'll show you in a second. The last thing I want to say is that the domain of the new graph h of x is the intersection of the domain of f of x and g of x. Essentially what's that saying is that whenever the graph doesn't exist for one of them, either f of x or g of x, it can't exist for h of x. Okay. Now I know that's probably very theoretical for at the moment, but now we'll jump into an example. So I've got g of x being the square root of x and f of x being x squared minus 1. So I've drawn both of those graphs there, x squared minus 1 and root x, and I want to draw what h of x is, which is it's f of x plus g of x. Okay. Now I go through my rules before. Probably I'll start with the last one. The domain of the new graph has to be the intersection of the domain of the other two graphs. So where does f of x exist? Well, f of x exists everywhere, but g of x doesn't exist everywhere. G of x doesn't exist before the y-axis. So therefore the new graph can't have all of these parts along here, because you can't add something to something that doesn't exist. So the new graph has to only be from x is 0 onwards. Okay, so that's what I'm going to draw. Now the other thing I want to do is my x-intercepts, identify any x-intercepts in either graph, and I've got one here and I've also got one there. Now I said that they stay the same because if you imagine I'm adding this point here with this point down here. Now if this point here is 0 and this point is -1, 0 plus -1 is just going to be -1. So on my new graph, that point is going to be -1. Over here, I guess I could find out what that is. I think that that's equal to 1. That there is the x value of 1, so I might even put that in, 1, 0. When x is 1 on this graph, I'm going to get 0, which means 0 plus whatever this is up here. It's going to be where the point is in the future. So that point there is 1, 1, because if I sub in 1 there, so I'm just going to get the y value of 1 and add it with the y value of 0, so that ends up being the same. So this point here and this point here will be on my new graph. Okay, so this point over here, that's the x-intercept, sort of there, and that one there is the x-intercept as well. Now the other thing I mentioned is the intersection points. They're doubled. The intersection of these two here, I'm not exactly sure what that is, but whatever that is, whatever y value it is, let's just say it's A, where are we? A and B. On my new graph, that y value is going to be doubled. So this is still going to be A, but it's going to be 2B instead of B because it's B plus B. Okay, so whatever that y value is, it's going to be doubled in the future, like at the same point in the future. Now, the only other thing I want to look at is the endpoint. So I guess I've already dealt with that one there. But the bits where it's positive and negative, and this is where it's not very precise, but it can help a little bit. What I'm going to do is I'm going to identify a bit here. We'll just say that point there. That is the same distance above the x-axis and below the x-axis. So that might be negative a half, and that might be positive a half. Positive a half plus negative a half ends up being 0. And so that's where this one ends up being over here. Okay, so I usually go through these rules to try and help me to understand, how to add these together. Another thing that you can do, just to get the gist of it, is you can put them on your calculator and kind of see how you go with that. It doesn't have to be exact. We just have to get the key points sorted. And most of the time, what they're really after is this. What's the domain of the new graph? And that's just, where both of them exist. So hopefully this has been helpful. If you need any more help on this, please let me know, and I can give you some more questions to do. So thanks.